multiple choice question. Percentage of certainty. The temperature change from that to that during a calorimetry experiment. Certainty was 0.1 divided by the change 21.8 minus 19.2. But because we've got a change, we've had two results. The highest temperature and the lowest temperature, final temperature and initial temperature. So we need to do times that by 2 and then times by 100 because it's percentage. So there's always one more step for these kind of questions. So the answer is 7.7%. Question 2. A volumetric flask was used to prepare 250 centimeters cube of solution. Solute was added from plastic weighing container. Each reading from the balance has an uncertainty of 0.005. What is the mass of solute? So we need to do the same thing again, times by 100, but same thing again. We've got two results, so we need to times it by 2. 0.005 times by 2 divided by 10.13 minus 4.48 times by 100. 0.1769%, 0.18%. Question 3. This is not a multiple choice question. The maximum errors for the pipette and burette shown below. These errors take into account multiple measurements. Estimate the maximum percentage error in using each of these pieces of apparatus. Use average title of that to calculate percentage errors. All we're going to do, and it says show you working, for pipette 0.05 divided by 24.25 times by 100, and for the burette 0.15 divided by 24.25 times by 100. 0.05 divided by 24.25 times by 100, 0.21%. In this case, 0.15 divided by 24.25 times by 100, 0.62%. Question 4. Carrying on with the multiple choice question. Which of these pieces of apparatus has the lowest percentage uncertainty? So what I need to do is just calculate percentage uncertainty for each one and then work out which one's the lowest. So in this case, it's going to be 0.1 divided by 25 times by 100. In this case, 0.5 divided by 25 times by 100. In this case, 0.001 divided by 0.150 times by 100. In this case, it's going to be 0.1 divided by 23.2. Because it's temperature change, we've got two results times by 100. Whereas the rest of them is just a mass with a balance with the certainty of that. And then once I work out each one, I can find out which one's the lowest. So 0.1 divided by 25 times by 100, 0.4%. 0.5 divided by 25 times by 100, 2%. 0.001 divided by 0.150 times by 100, 0.67%. And this final one, 0.1 times by 2, 0.2 divided by 23.2 times by 100, 0.86%. So the answer is A. That is the one with the lowest percentage uncertainty. Question 5. This one's a bit weirded differently. A measuring cylinder has an uncertainty of 5 centimeters cubed. What is the minimum volume of liquid that can be measured if percentage error is to be less than 0.20%? So we need to find out percentage error for each one and then work out which one is lower than that. So we need to firstly convert in centimeters cubed, so that's times by 10 to the power 20, times by 10 to the power 3. So 5 divided by 0. I'm just putting a calculator. 5 divided by 0.025 times by 10 to the power 3, which is times by 100. Oh, I don't need to times by 100. And I need, in this case, 0.20%. Wait, what? So, what's the minimum volume of liquid the volume is to be less than that. So 5 divided by 1, 2, 3, 25 times by 100, that's 20%. 20%. 5 divided by 250 times by 100, that's 2%. 5 divided by 2.5 times by 10 to the power 3 times by 100, that's 0.2%. And the final one, 5 divided by 25 times by 10 to the power 3 times by 100, perfect, 0.02%. And the reason I don't stop at C is because it says can be measured if the percentage error is to be less than 0.20%. It's not A, that's 20%. It's not B, that's 2%. C, that is 0.20%, but it's not less than that. Therefore, the answer is D. 0.02%, that is less than that. And the final one, question 6. The maximum uncertainty when weighing this much on the balance of that was a percentage uncertainty. 0.001 when weighing this much on a balance, 0.250 times by 100. 0.001 divided by 0.250 times by 100, 0.4%. And that is the end of the multiple choice questions.